EnterCalc 3D has the ability to perform steel column design, and we'll use this simple model to take a look at how that's done. We won't go into the details on model construction in this video, but it is important to understand that in order to use the steel design functionality, we have to have a model that actually is stable and will run and produce analysis results. So in this model, I've assigned sections, I've assigned materials, loads, supports, everything will actually work once we go to run it. The one thing that I do want to take a quick look at is load combinations. They're important for steel design. So when I open the load combinations dialog, we can see that it comes in with the default load combination automatically. Nothing to worry about there. Beneath that, we can see a list of IBC load combinations that I've automatically generated using this button. And the important thing with these is that they're all set to yes in the run column. They're all set to yes for a P delta analysis, and they're all set to yes for steel design. So with that, we're ready to get some analysis results and take a look at steel design. The analysis only takes about 3 or 4 seconds for this model. Once that's done, we can say close, and then we can come over to the Steel Design tab, and we'll just work our way through the buttons. The Steel Materials button opens the Steel Materials dialog. This lists all the materials that have been defined in the model. In fact, the only material that's been applied in this model is the A992 steel, but the purpose of this screen is to define the Fy value to be used in steel design and the Fu, the ultimate strength, to be used in steel design. I like those values already, so no need to make any changes. I'll just click cancel. Next, we'll go to steel design criteria, and we'll start with the screen that's also named steel design criteria. This is where we can select the design code, and notice that there are a bunch of options here that help us to sort of dial in on exactly what we want the analysis and design to use for parameters so that we can refine our designs. We won't go through all of those in detail, but everything is okay for my purposes, so I'll click cancel. Back to steel design criteria. The next item is steel member design criteria. In this table, we can create as many different steel member design criteria as are necessary to define all the members in the model. Now, since we're only designing the one member in this model, we only need one line. The table allows us to create a meaningful label for each of the different design criteria that we define. The next field allows us to specify what sections we'd like to have considered. So this is the nomenclature to use to tell the program that we want it to seek out a W12 or W14 section size for the member that we're focused on. Then we can indicate whether the member or the frame is subject to X direction sway, Y direction sway. Is the member continuously braced? If not, what is the unbraced length? We can specify the CB value and the K and L values for axial design. The last field is a maximum capacity ratio in case we want to allow something other than 1. Those all look good for me, so I'll click cancel. Back to steel design criteria. The next item is steel section pool. The steel section pool is a way that we can draw from the AISC table to select specific sections that we want to have tried in the design. But we already told the program that we want it to look at all of the W12s and W14s, so I'll just cancel out of steel section pool. The last item in the steel design criteria menu is Exclude steel elements. This tool allows us to tell the program specifically which members we do and don't want designs for. I've already excluded everything and then came back in and included this one column in the foreground. So we don't have any work to do there. The next button is Steel Member Design Properties, and this is just a tool that allows us to assign the previously defined criteria and inclusion or exclusion status to the selected entities out in the field of the model. Again, I've taken care of all of that, so no work to be done with this tool. The Steel Member Input button opens up the Steel Member Input screen. This is basically a tabular view of the same information. It lists all the members in the model, the design criteria that applies to that member, and the inclusion or exclusion status of each of those members. So looking at member number 12, we can see that's our column. That's the only one that's included, and I don't want to make any changes here, so we'll click cancel. Okay, that's all of the input that's required for steel design. The next step is to just click Perform Steel Design. That zips through in no time, and we can click Close, and now we can start to look at steel design results. So on the steel design results table, we can see information about the one member in the model that we've asked for design results for, its length, the section. Notice that the status is indicating no good and that the ratio is 1.27. So we have some work to do here. We can see the load combination that's causing that controlling ratio. We can see that it happens to be a combined axial and bending ratio at the very beginning of the member. And then there's other design information like shear ratios, deflection ratios, and design loads. But our work for now is to come back to the section and try to figure out how to make this work. Now notice that there's a drop-down arrow here. When I pull that drop-down menu down, we can see a listing of W12 and W14 sections listed in order of increasing weight that quickly and easily allow me to try sections that fall within the families that I chose by just selecting another section. Now, when I bump up from the 1265 to the 1287, a couple of things happen. Number one, we see an OK status and a 0.9, roughly a 0.92 critical ratio, but the other thing that's important is that the line turned yellow. The reason for the yellow line is because we're now mixing and matching. We're performing a design on a W12 by 87 based on forces that were determined when the stiffness of a W12 by 65 was used in the model. So not technically 100% accurate, but it's a good sign anyway that things are getting better by picking the bigger section. What we can do to make it official, if we want to try that W12 by 87, is come down to this Update Sections button. When we click that, this message tells us that updating the sections is going to invalidate the current analysis and design results. So do we really want to continue? Well, yes, that's the purpose of pushing that section back into the model, is to be able to come up to analysis and reanalyze with the changed stiffness. Now we can say close, come back to steel design. We don't have any work to do as far as setup is concerned, but we do need to tell the model that we want it to perform steel design again. And then we can come in and take a look at steel design results. So now notice that when we reanalyze with the W12 by 87, the ratio did change. It's no longer 0.92, but it is still okay. And all of the good design information is over here if we wanted to take a look at that. The other thing that's convenient in this screen is the Show Calculation Procedure button. And when I click that, it uses the browser to open up a calculation that very closely resembles a hand calc. So we can see all of the input information associated with that W12 by 87, and then checks all the way down the line, intermediate values and results that we could easily send to the printer for this calculation. So that's very handy to have. Now I'll click cancel, and I'll just mention that the Steel Design Tools is here. It's not part of the normal button flow or ribbon flow, but it does offer some utilities that can be useful for checking and designing steel sections, as well as a K calculator. Um, the last button is the Unity Check toggle. And what that does is it toggles on colors where blue indicates a passing member, and if you had any members out there that were failing, those would appear in red. So hopefully that's a useful and helpful look at how steel column design can be done in EnterCalc 3D.